Hello everyone, myself Shreya. In this video we shall be talking about the topic beyond CMOS, which is the future of semiconductors. So a little overview of what we'll be looking at in this video. First we shall discuss what is beyond CMOS technology. Then the CMOS and the evolution of CMOS. What are the possibilities beyond CMOS technology? And then one of the beyond CMOS technologies called MISO. And then what are the innovations that are possible when beyond CMOS technology is developed. And then we shall conclude this video. So moving to the first topic, what is beyond CMOS? Beyond CMOS refers to potential future digital logic technologies that expand beyond the present CMOS scaling limits. These limits are designed so as to keep the device intensity and speeds in check in an effort to combat the heating effects. Digital logic is an important aspect in creating electronic and logic devices, which allows to create circuits, check important computer chips, and perform certain other functions necessary for a system to run. This means that beyond CMOS refers to future technologies concerning digital logic or future technologies which is what we rely on to represent the sequences and signals within a digital circuit. So the next slide is evolution of CMOS. How has the CMOS technology evolved? For more than 30 years, the performance of integrated circuits has consistently seen exponential improvement. But the history of CMOS reaches much farther back than the past 3 decades. The technology was invented by Frank von Liszt in 1963, but CMOS technology did not become mainstream until the introduction of 256 kilobytes CMOS DRAM in 1984, and since then has been essential in constructing integrated circuits, microprocessors, microcontrollers, sensors, RAM, and a host of other digital circuits. Since the fateful discovery that an integrated circuits transistor double every 18 months, much has changed. Conventional CMOS presents a number of challenges that dedicated researchers have had to expend considerable energy overcoming. Problems like high gate leakage current, high source to drain leakage, gate stack reliability, and channel mobility degradation have all been an essential part of CMOS evolution. Within the past 15 years, a new CMOS technology node has emerged approximately every 24 months. Each node has its own changes, generally 2 times density shrink and approximately 35% performance gain per node. Chip power capabilities have steadily increased and power limits have driven the process of CMOS scaling to a more density-focused process. Next is, why is the beyond CMOS technology possible now? So the beyond CMOS technology is not really possible now. A small offering are available on commercial levels, but the general public is not working with the devices that incorporate beyond CMOS capabilities. What is possible now is working towards these capabilities. This work on beyond CMOS is possible due to the alignment of several factors: need, outside technological advancement and innovation, and an exceptional level of flexibility. The potential for scaling CMOS technology is rapidly approaching an end. With no other options in sight, researchers and academics worldwide are pushed into considering technologies like these out of sheer necessity. Obviously, the immense work devoted to the evolution of computing over the past several decades has contributed to presently ability as well. Professional research groups are deeply concerned with magnetic devices, resistive switching electronics, and a number of other technologies and capabilities that have all been researched for some time prior to now. Because of the scope of potential beyond CMOS technologies is fairly large, researchers have also a great deal of flexibility in terms of where they choose to place focus and channel lengths. This means that those who are experts regarding circuits and architectures, for example, can focus on those and offer thorough insight into development. Meanwhile, other groups can channel their work into creating nano or micro electromechanical systems or improving the magnetic logic. These factors combined with the work of forward-thinking individuals and groups who identified the need for this technology in the first phase have granted us the capability to begin striving towards beyond CMOS technology. Without the many avenues for research, the many niches to select from, and outside advancement pushing things along, it's entirely possible that research and development would stagnate. Now we'll look at a technology called MISO. In 2021, IEEE International Electron Devices Meeting, Intel demonstrated for the first time a functional MISO, which is Magneto-Electric Spin Orbit Transistor. MISO is also called as Beyond CMOS device. That is, it represents a fundamental new way of building a transistor and uses room temperature quantum materials. MISO could be 10 to 30 times more efficient than existing transistors and could help spur artificial intelligence efforts across a variety of industries. Although still in research phase, MISO would represent the biggest advance in computing since the introduction of the transistor if it reaches commercialization, and would likely lead to revisions in electrical engineering courses and textbooks. Intel's prior theoretical research had shown that MISO could offer significant advances over conventional transistors in the energy consumption and chip area. MISO could allow circuits to run at just 100 millivolts and would be especially promising for applications in artificial intelligence chips. So these are the innovations that will be possible when the beyond CMOS technology is invented. The cryogenic electronics are anticipated to have a potential initial application areas. Sensors may be capable of improved accuracy, resolution and rate. Signal and media processing may also see the improvements. Digital and quantum computing capabilities will likely see a sharp increase, resulting in improvements concerning operations per second, energy per operation, and coherence time. Magnetic logic is expected to be another key opportunity born from beyond CMOS. Researchers have proposed that the M logic, or the logic based on novel magnetic devices, will make an ideal technology for electronic systems in energy constrained environments. These systems will be powered by notably low voltage and are anticipated to be 3D stackable, resulting in high density logic and memory. So I would like to conclude this by saying that the beyond CMOS technology won't be available to be used for consumer for the next 10 to 15 years at least. But a lot of alternatives are being researched by the scientists and researchers and will be soon available for us for the consumer usage. Thank you.